Welcome everyone. Today's video will be a little bit theoretical, and I will show you how to have a relatively fast communication between your microcontroller, Arduino-based microcontroller, and your computer. So there are several options for sending data from your microcontroller to the computer, and I will go through these options, and I will try to show you a good way to send data, specifically numbers, to the computer and just dump a huge amount of data on the serial port. So I will show you two examples, and then I will also show you source code for capturing this data. I wrote some small terminal in C#, and then we will see how it works and what are the differences. So here is the Arduino code, and I will start to explain what is what, and I will explain some certain details in more detail. So I want to keep track of the time, so I defined a start time variable. So this will be stored in float, and it will store the time in micros. So this will be our timer. And I will run certain things in loops, so I want to keep track of the number of iterations, so there is another variable for this. I have a test number, and in this case it starts from 0. It's an unsigned integer and 32 bits, but I will use this as a 24-bit number because on the receiving side I am preparing for receiving 24 bits. And this is very important, that you have to write your code according to the type of your variable. So if you just send 8 bits, you have to treat those 8 bits. If you are sending 32 bits, you have to take care of those 32 bits. But if you follow this example carefully and see what I do, you can tailor this to any kind of applications. And then we will have a buffer of 3 elements made out of bytes. So we will store 3 bytes or 24 bits in this buffer or array. So I call this test buffer, but this is an array with 3 elements in it, and each element stores a byte. The setup file is very simple. I just have a serial started here, and this is at 2 million. It doesn't really matter if you are using STM32, and I'm using STM32 Blue Pill in this example. So here it seems to not matter, but I just try to use the highest number as possible. And then after initializing the serial port, I just wait a second, and then I print a message on the serial terminal, just because why not? And actually we can skip this part to not interfere with certain features of this code, but it depends on how you receive the data. And then we have a loop which does not loop as long as you don't do any specific things. And what we do is that we are waiting for a character on the serial port sent from the PC to the microcontroller, and we check that character with the switch case statement. So first we read the serial port and save the character in this variable, and then we check that character in this switch case part, and we see whether we sent B or D. And the first one will test the binary communication, which will be our high-speed communication, and the other is checking the decimal, or actually this could be string, but I just call it decimal. So the second one is testing the decimal, so we just send the D. So let's start with the binary. So with the binary, we will not use the serial.print or serial.println, which is just a print with a line break, but we will use the serial.write. So here we just say that our test number, which we defined up here, will start from 0, just to make sure we zero it out. And of course the loop counter, which counts the iterations inside this while loop down here, that also starts from 0. And we start the start time by checking what is the time according to the micros and save it in the start time variable. And then we start our while loop. And what I want to do, I want to iterate this loop 5 million times. Actually, this is 5 million here. So I want to loop through this 5 million times. And what happens here is, if you remember, I declared a 3 sized buffer. So it can store 3 bytes. And we start to fill up that buffer. So we have a 24-bit number at the end. And how we do this is that we read the test number, and then we use the bitwise AND operation and end it together with 255. And I will show you why we do this. So this happens, and this will be the 0 element of this array or buffer. And if you want, you can print this out. I just commented out, but this is just my checking. But then after we filled in the first part, we move to the next part. So the second part of the buffer should be the following. So we have the test number, which is the number that we want to print on the other side on the computer. Now we need the middle part of it. So we have to shift to the right by 8. And then again, we just want to keep that part from the whole 32-bit number. So we just use the bitwise AND, and we end it together with 255. And then we go to the last part of this 24-bit number. So this is the third byte in it. And we take our number that we want to print. We shift it by 16 bits. So we just have the last 8 parts of the number, the last 8 binary numbers. And then again, we just want to keep that in our buffer. So we have to end it together with 255. And once we have this, we pass these whole things, so the whole buffer to the Serial.write method. So that happens here. And then we also say what is the size of this buffer. And then with this the content of the test buffer should end up in the serial port and should show up on your computer. And after this, we increase the loop counter, so now this will be 1. And I also say that, okay, the value of the loop counter will be the test number. So the next time when we iterate through this thing, then the test number will be 1 instead of 0. And then the 1 will be like sliced up to 3 parts and then passed to the serial terminal. And I made another thing here is that if the elapsed time is larger than 5 seconds, we just jump out from the whole thing and we just stop doing whatever we did. So I was curious which is reached earlier. Can we send out 5 million numbers, or 5 seconds elapses quicker? And now, before moving to this part, which is more simple, I want to explain this in a bit more details. So I wrote a few thoughts here, and let's go through those points, and then I show you what is in this table. So how Serial.write works. So this is basically just the code explained in text. So we want to send 24-bit numbers from the microcontroller to the computer through the serial port. But the problem is that we can only send 8 bits at a time, or 1 byte at a time through the serial port using this kind of method that I'm doing. So then we have to think how we can solve it. And the solution for this is that we have to decompose our 24-bit number into bytes. And how we do that is very simple. It's just a division. So we have 24 bits as our number, and we want to split it up into bytes. And we know that 1 byte is 8 bits. So we just divide 24 by 8, and that gives us 3, of course. So we need 3 1-byte buffers, and that's what I showed you in the code. So now you see how this works. And then what this byte array, which was the test buffer, does is each of these elements inside the array stores a byte or 8-bit portion of the 24-bit number. So that's why we need the 3 elements inside the buffer. So what you see here in the table is we have the 3 bytes, and then I colored each byte package with one independent color. And so this is our 24-bit number up here. So now we have to check how this works. So we have the buffer 0 here. So this is like the first element of our buffer. And we take the whole number. So again, this thing here, and that's the number. And we have to use the bitwise AND operation, this, together with 255. So then 255 is technically this. So you write 1 everywhere. And then you have your number above in the green cells, and you have your ones everywhere because that's the bitwise operation. And then you have to just run the operation technically. So I just write down some kind of numbers here. So this is our number. And then we need the 255, which is just all ones. And when you use the bitwise AND operation, then you just basically copy these numbers if you have a 1 here. So then essentially you just write down the same number here. And why is this important? Because if you have numbers here, anything which is about 255, so these become 0. And when you use the bitwise AND operation, that means that these zeros delete these numbers. So then what you are left with is just this portion of the number. And that's very good for us because this is erased. So of course you have the other parts of the numbers, but they become 0. So then you just concentrate on this part. So this is how we made the first element of the buffer. Then we move to the next one, and the next one, first we have to do the operation in the parentheses, and that says that shift our original number to the right by 8 bits. So here is the original number, and we go to the right. So what happens is that the green part is being shifted out. So the greens is somewhere here, but it's not in the number anymore. And of course these parts become 0, so all these 8 bits. So then we got rid of the first part, and then the middle part which we will need is actually at the good spot, but we still have numbers here. So we use our trick from the previous example, and then we just end it together with 255, which means that we only keep this part, the orange block, and everything else becomes 0. So then in the second buffer here, we kept the middle part of the number. So essentially we have this part here. And then the last one is the same, but we have to shift more. So now we have to shift to the right by 16. So we go to the right, which means that we get rid of the orange block and also the green block. So what we are left with is technically just this part. And I believe that we do not necessarily have to use this, since we shift from the left to the right. All other things are technically just 0 over here. But just to be sure, and just to make sure that we just keep these first 8 numbers, we just use the bitwise AND operation with 255. So then we really just have these numbers. So this is how the code works when we send the data, which is 24 bits, in 3 chunks to the computer. So then let's go back to the Arduino code and let's look at the other code. So then we arrive to the other part of the code, which is the decimal part. So we are sending out decimal numbers as strings here. So what happens is that we have the loop counter, and we don't need other variables because we will just send the value of the loop counter to the serial port. And then we need a start time just to keep track of the time. So if a certain time elapses, we just interrupt the connection. So either we go 1 million cycles within this loop and we iterate 1 million times, or we step out if the 5 seconds is over. So what we do here is we use the serial.println, and then we always print the value of the loop counter on the serial port. But here we will print strings, and this can become slow. So then after printing, we increase the value of the counter. So after one iteration, loop counter becomes 1. And then we check if we passed 5 seconds or not. If we did, then we just print another message and just step out from this while. So we will not stay there anymore. But if this is not yet fulfilled, then we go back to the beginning of the code. So we come up here and then we just print out the next number. So now I will show you my terminal, and I show you how it works, and I show you the differences between the two methods. So first we will look at this method. So this is my small terminal, and it is extremely simplified. So all we can select the COM port. I have already connected my STM32. And then what we can do, we can save everything into file. We can print it on the terminal or not. I do not enable it right now, because if we print the text to somewhere, then that slows down everything. So we don't want to print the text over here in this text box. But here in the total buffer size and the buffer size, you will see how the data is coming in. And also here I can select binary, which means that we are receiving the numbers in binary. So the terminal will know that it has to process the binary numbers, which are these guys here in the background. So what I have to do, so the Arduino code which you see in the background is waiting for a character B. So I just send that. And now I just have to press send and wait until this finishes. So now I press this, and you see the numbers increasing. And it's done. So the total buffer size was 1.6 million something something, and now the buffer size here is empty because we shifted out everything from our temporary buffers. And this was just like a rolling counter, so it just adds up the total amount of numbers which passed through the serial port. But of course this is just part of the truth, in a sense that this 1.6 million is all these numbers in the background. So you have to divide it by 3 because you create 24-bit numbers from these numbers. So these are the number of bytes which were sent through the serial port. So now if we look at this, we can expect 500,000-ish numbers. So now I open the output file, which comes here, and you can see this iteration. So this is the value of the loop counter, and you see it started from 0, 1, 2, 3, blah, blah, blah. And then here we go. So the last value here is 551,538. So what happened is that within 5 seconds, we were able to send out more than 5 million 24-bit numbers. And how do I know that this happened within 5 seconds? Is because I set this while to 5 million, and we don't have 5 million numbers here. And therefore this means that this timing was triggered earlier than the while loops condition. So we have roughly 500,000 numbers within 5 seconds. So that brings us to roughly 100,000 numbers, 100,000 24-bit numbers within a second. So that's more than enough for any kind of high-speed acquisition. So now it's time to test this part. And this part, once again, it just sends the strings to the serial port. So let's see what that does. So I restarted the software, so I connect to the serial port. I want to save it into file, and this is not a binary, so we don't need the processing. and we need a decimal number. So I send this. I have to wait a bit. And now I see that the output file is generated. So here is the output file. So once again, we started printing the loop number here, the loop counter. And then if I go to the end, we got the message. So time is over. So this, within 5 seconds, was able to push out 93,000 numbers. So that brings us to roughly 18,000 numbers per second, which is quite good, but that is nowhere near. So it's roughly 1/5 of our other result. So this is, I think it's amazing, because you can have 5 times faster communication by using the Serial.write, and this is like really the proof of it. So you see all the numbers here, and this is the pure output of this code here. And this code does nothing else, just increases the counter and then prints it, increases, prints it, and then when 5 seconds is over, then it will break this loop if we haven't reached the 1 million points. And this is obviously 10 times less, more than 10 times less than 1 million. So we stopped before reaching 1 million because the time 5 seconds was over. So I gave both functions 5 seconds, if you see, but Serial.println was able to just push out 100,000 numbers, let's say, and Serial.write was able to push out 100,000 numbers in 1 second. So this was for 5 seconds with these functions. But yeah. So now I show you how to write your own terminal, and maybe this is not the best practice. I'm not a programmer, but as long as it works, I think it's quite okay to use this. So as I said, I wrote it in C# using Microsoft Visual Studio, and yeah, I think I don't have to really explain how I put this together, because it's basically just drag and drop. I put together some text boxes, combo boxes, some buttons, and I also put some timers, namely 3 timers on the window, and also I had to include a serial port. But the code is more interesting. So we need the I/O ports, of course, and the lin queue, because I'm using lists. So what happens here is I have a bunch of variables and I just quickly go through them, but when you read the source code, you can process them yourself. So of course we need one variable, a serial port variable for the microcontroller serial port. So this is why it is MCU. And then I make sure that I know the status of the serial port by storing its status in a variable. So whenever I open it and I connect to one of the COM ports, I change this to true. And then I need a bunch of things for buffers, and I have different buffers. So one will store the incoming data, which is just a list of bytes, and this is technically a matrix, not a list, because I store an array inside this list. And then I have a real list, which is just a list or a vector, sort of, which is the file buffer. So this is for storing the files, storing the data before writing it into a file. Then I have a serial buffer. This is grabbing the data from the serial port. And I have an array because I want to flatten out this thing. And then I keep track of the total buffer length. This was this 1.6 million that I showed you in the main window during the test. And then finally I have the converted number, which is the final result, which is a 24-bit number. And then I have the string related variables. So this will be communicating with the other Arduino code when we are using the Serial.println. So we have the incoming string, which just looks at the serial and looks for the string. And then we have a buffer for that. So we are storing the numbers, or the strings, sorry, in a list. This variable makes sure that we know the path where the exe file was started, and this is good because then when you want to place the output file, the txt file where you store the data coming from the microcontroller, it will know that it has to be next to the exe file because it knows the path of the exe file. And then I store the date time. This is somewhat similar to the micros in the Arduino, but this stores the time in a much complex format. But at the end, we just use dt1, dt2 to store the date time. And also, I want to know the elapsed seconds. This will be for timing purposes, to time the timers for the buffers properly. So this is all about the variables. And then this is an event handler. So whenever I change the selected index of the drop-down list, so I select something from this drop-down list, we will try to create a new serial port when we selected one. So I don't go into details, but these are just the standard things that we can define. Maybe this can be changed to higher or different values. I'm not sure, but this is how it works for me. And maybe also the character which indicates the new line can be Rn and not only n. And what we try here is that we try to open that selected serial port, and if we succeed, we also change this variable. But if we have some problems, we have an exception and we print that there is an error. And now we go to the send button clicked. This is also an event handler. So when I click this button, this function will run. And what is happening here is that we check the port if it's opened. So this is why I stored this status here. And if it's open, we try to send the content of this text box to the serial port. And if the checkbox for the binary input is checked, so this is checked, then we start two timers, because when we are using the binary communication, we need to poll the serial port. And how we poll it is that we check the serial port first, and we fill up certain buffers, and then we have to pass these numbers and process these numbers in another, let's say, thread. Maybe this is not the best word in this kind of scenario, but we take care of it in a different thread, and that is why we have the print timer, so that will like print it to the window or into the file. But if the checkbox, once again here, is not checked, we know that we are expecting string, so we start the timer of that. And we also start the time here. So whatever we did when we pressed the send button, we have to start the timer. So that happens always. Catch is not implemented here, and if the port is closed and we still try to press this button, then the user will get a message that, hey, there is no ports opened. Another event handler, it doesn't really matter, but whenever you close the software and there is an opened port, so you are connected to your microcontroller, this part makes sure that it closes the communication. Another event handler, whenever we start the port, whenever we start the software itself, so we just open the exe file and this thing shows up, we try to get the available ports. So if you see down below, we just fill up an array with the available ports which we see with the software, and then we fill up that combo box or drop-down list, this here, and they become available, so we will see which COM ports are visible. So now comes the bit more tricky part. So what this does is the serial check timer is polling the serial port continuously and checks if there are bytes to read. And what this means is that if there is any kind of data, we fetch that data and we put it in an array. And then that array will be further processed. And how we do this is We stop the timer here, so we don't want this to tick anymore, because this ticks very quickly, maybe quicker than these things are performed, and that might lead to some confusion. So we have this variable, the bytes to read, and that is 0, of course, in the beginning. We check that the timer is stopped, and then we try to check on the serial port that what is the amount of bytes to read, and we save it in this variable. So let's say this was successful, and let's say that the port is open, and if the port is open and there are more than 0 bytes to read, so there is something on the serial port waiting for us, we have this serial buffer, which is a buffer of which is an array of bytes. We create a new serial buffer here with the size of the bytes to read. So then when this happens then we once again check if we are still open, but this might be deleted because we already checked it here. That's why I put this comment here. So when this happens is that we read this serial port that we opened, and then we put everything in the serial buffer time without any kind of shifting, so that's why it is 0. And this is the amount of things that we try to read. And when this is completed, we have this big array, and then this array is put in a list. And why I'm using list is because we don't have to know the size of it in the beginning. So sometimes you receive more or less bytes than you expect because of some speed related things or something. Then you can have a dynamically increasing or decreasing size, and that's why I put this in a list. So then this is fine. So we copied basically the whole value in this list, but as I mentioned in the beginning, this is a matrix now because we put an array inside a list, so that becomes a matrix sort of. So then we want to make sure that we know what is the total buffer length, so the total amount of bytes which we captured from the serial port. So then we always add the bytes to read to this number, and I also refresh this. So that's what you see here. So this number will be more and more. And I just remove this part, it's commented out. This is just for checking the things. So I just print out the numbers. So this is basically the 8-bit parts printed in this text box, but now we don't care about this. And once everything is finished, we can start this timer. So this whole thing runs at every tick of this serial check timer, and then you can set this up to anything. I'm now using 10 milliseconds. And now we have a print timer, and this is similar to the previous, so the strategy is the same. We are just copying numbers between arrays, but what is happening here is that we take the data from the serial port that we just recently captured and put here in the incoming data list, and then we further process that. So we need an array, and we will call it buffer array, which will be as long as the total number of captured numbers, or bytes to be more precise. And we want to flatten it out because now the incoming data is still a matrix. So what we do is that we use this kind of functions. So select many, and we convert it into array. So the x by x or x by 3 thing becomes just a vector, so it's just an array. And now, since we flattened this out and copied the content into the buffer array, we can clear this out. So we free up the space. However, since it's a dynamic thing, we don't really have to free up any space because you just keep adding to the end of this list. But the purpose here is just to free up memory. So this is done. And I also want to know the length. So first of all, I have the length of this total array. So the length of this is known. And then I also want to know the number of numbers or amount of numbers which are the number of 24-bit numbers. And we know that the 24-bit number consists of 3 bytes, so 3 8-bit numbers. So the total length has to be divided by 3. And that's done. And I just print that out. So then I know that this buffer size will be that number. So whenever this print timer ticks once, we will see on this label how many 24-bit numbers are saved out at each tick. And the frequency of this tick is 1 second. So we are collecting a lot of data in the incoming data buffer. And then after 1 second, we just copy everything out and we further work with it. So now there is some checking here. It doesn't really matter, but what happens here is the most important thing. So if you remember from the Arduino code, we had to decompose our number, our 24-bit number, into 3 bytes. And now we do the other backwards, but there is some twist. We have a certain amount of numbers that we have to convert, and we have to know this in a nice manner. So what we do is we have a for loop here, which starts from 0 and goes as long as we have numbers in the array, 24-bit numbers. So this will be our final result, and first we have to make it 0, and then we do the same bit shifting but backwards and upside down, sort of. So first, the converted number will be the buffer arrays 3 times I plus 2 element, so the last element in the 0th iteration, because when I equals 0, this part is 0, so the total thing in the square brackets will be 2, and that's the 3rd element of the array. So we check that, and that is the MSB, or most significant byte, and that MSB is shifted to the left by 16, so that takes up the first block of the 24-bit number, as I wrote it here as well. And then in the next, we take the middle number, so this will be 0 and this will be 1. So in the I equals 0 iteration here, the square bracket will be 1, and that's the middle. So we just shift from the left towards the left, by 8 bits. So it will be in the middle, so 15 to 8-bit position. And we use the bitwise OR because we have to combine the previous number with this new number which we created here. And finally, we have this part where we have a 0 in this, in the I equals 0 iteration. So this will be the 7 to 0 bits, and that has to be combined with the converted number. So then we have our total or whole number, which is the 24-bit number, and we add it to our file buffer. And the file buffer is our buffer, which is a list, and that will pass the numbers to the output file, because it's quite stupid thing to always open your file and then write into it and then close the file. Instead of that, we keep collecting a certain number of data, which in this case 24-bit numbers. And once we reached some kind of threshold, here is just a timer, we dump the content of this file buffer into our txt file, and then we carry on. And here you can see that if I enable the printing checkbox, which is this guy here, the print to terminal, then the results are printed in this text box here. But as I said, it can slow down the things, so I would rather skip it when it is not necessary to see the data real time. What you can do here is that you can skip certain number of data. You cannot see more than whatever 24 frames per second anyway. So let's say just to have some satisfying flow data, you want to print always just 60 numbers, the 60 most recent numbers. And that will not really slow down this process, because 60 is technically nothing compared to 100,000. But you can still see what are your most recent numbers. But for that, you have to write your own thing. So coming more down, we have the timers, which we haven't used yet. So here we check the date again. So basically just we put the datetime.now into this dt2 variable, and then we calculate the elapsed seconds by calculating the time span between dt2 and dt1 and express it in total seconds, so that the number here will be stored in seconds. And then here is a very simple if condition. So if the elapsed seconds is larger than 3, so we hold 3 seconds equivalent of data, then we run this print to file function, and then we dump the content of the file buffer into the txt file. And now we have to count again this 3 seconds, so the dt1 has to be restarted, because that just restarted once and not with every ticks like this rest of the function. So then dt1 is, let's say, 0 now, so we start counting the difference between the date here and then the date here, and then we count to 3 again, and then it will be printed. So this is how, I think this is the core of the whole thing, to reconstruct the 24 bits from the 3 bytes. And then we can jump to the next thing, which is the serial string timer tick. This is again polling the serial port quickly, and it is reading out the strings. So this is working together with the serial.println function, which we use in the Arduino code. And what happens here is that, of course, we are curious about what is the amount of the numbers that we want to read, but here actually we don't really care about the exact number, but we just want to see if there is anything to read. And that's what happens here. And you see that this is a very short code. So we see, yes, the serial port is open. Of course, this should be open, otherwise this could not work, but maybe something can happen. Meanwhile, you just unplug the connection or something. So then if the port is still open and there is something to read, so that's why we did this kind of checking, then we have this incoming string, this is just a string, and we read the existing thing on the serial port. So we dump everything as a string into this variable, and this also contains the line breaks, so that's quite good for us. And after that, we just put this string, the whole thing, into a string buffer, which is just a list of strings. And finally, we can restart the timer, and then we can move on to the other kind of timer. So this is the same strategy here, the selected text, as I did here. So we just check the dt2 again, and we calculate the elapsed seconds. If the elapsed time is more than 3 seconds, we print to the file, and then we sort of reset the timer, so the 3-second counting starts over. And how this print to file works is relatively simple, as you can see it here. So if the file save checkbox is checked, this guy, then we run another if, of course, because we have to check whether the binary was checked, this thing here, or not. So if that was checked, then here we have a for each statement. First of all, we either create or append to this text file here. So there will be a file named output file in the same spot where you stored the exe file. And then this for each loop will dump everything from the file buffer, and just since it's an integer, we'll write it line by line. And then after we finished with this, we just clear that buffer so we can save some memory. And if the binary checkbox was not checked, so we were working with strings, everything is the same, but here the for each, instead of iterating through integers, it will iterate through strings. It checks the incoming string buffer and then prints that the text into the output file line by line. So then after that we can clear the buffer. So this goes over and over as long as you have data and coming into the serial port from the microcontroller. But as you can see, this was relatively simple, but I think this is very good because many times I got problems with slow communication between my microcontroller and the computer, and I needed at least 50,000 Hertz, and now I can provide that. So this works very nicely. So technically this was the video. I just wanted to show you how to communicate very fast, and you can see that the better way is to use the Serial.write from the Arduino, and then you have to know how you format your data and how you send it from the Arduino, how you receive it, but you can see that this works quite well. But once again, I have to say it again, I'm not a programmer, so maybe there is a better way to do this. I pretty much believe that there is, but this is my way and it works for me, and I hope that it can also help you. And please, once again, check the description of the video because I put all the resources there, so then you can find all the source codes and so on, and you can test it yourself. It was a long video, but I hope you learned something. I hope this video was useful to you and you can speed up your Arduino projects. And see you in the next video.